everyone, welcome to APS Deep Academy and this is your mentor Swati Joshi. In this class, we will study about electronic circuits and their components. So, an electronic circuit is a combination of electronic components and conductive wires which are interconnected in a way to achieve an outcome. Now, what are the outcomes? Let us discuss. The first is achieve a current voltage of a certain value. We know that electronics is electron mechanism. In first day, I already tell you in first class. Okay, now in electron mechanism, what we are doing? We are just manipulating the flow of current according to our need. So the first outcome is related to that, to achieve a current or a voltage of a certain value, to perform a certain or specific task. Now the second one is amplify a signal. Okay, we know that in digital communication, we use electronic circuits as frequency amplifier. So, the voice or the signal we can amplify with the electronic devices or the electronic circuits. The third one is transfer data. We know that in digital electronics, we can use electronic devices as coder or decoder. So, due to the property of these coding and decoding properties, we need a circuit which can transfer or manipulate the data. So, here few of the outcomes are written. This is not the limited output. We can do many more phenomenal tasks with the help of electronic devices. But as a student of basic electronics, we need at least these three. These are the major or basic. Now, what are electronic circuit? We know that in any circuit, one input is there, one output is there, and one circuit mechanism is there. Similarly, in this also. So, what are the purpose of these components which we are telling today, which we are discussing today? So, the purpose of this electronic component is to allow the designer to control the flow of currents. Our first task is to control the flow of current. That's why it is electronics. So, to control the flow of current, to achieve a specific output. Okay. Now we will discuss these components in detail. First, we will discuss classification of components. So, according to classification of components, components are classified as active and passive. Now, let us discuss what are active and what are passive. So, active components require external power supply to operate. Now, what this term means? This term means that any active component like a diode need an starting operating voltage to start the conduction and start its working. But passive component, they don't require any external power supply. We can say that like in register don't need any external input to start and perform its task. If I put a register in a circuit, it will just simply register the current and do its task. So in passive components, we do not need any external input to start, but in active, we need that. The second one is active components, they have a function of gain. Now, what is the function of gain here? Gain is something you can relate it with if I have a specific input and I have a specific output. If I can calculate the ratio of it, so this is the gain of devices. Okay, so the gain is different input, different output. So we are calculating again. If I talk about the amplifier, the input signal is weak, output signal is little strong. So we can calculate a gain of that device, how much gain it is giving. So active devices have a function of gain, where passive devices don't have the function of gain. Okay. Now the third one, active devices produce energy in form of voltage and current, and passive devices, they store energy in form of voltage and current, like we use as in capacitor. We just store the energy. Examples of active devices are semiconductor, diodes, and transistors, and passive devices we have inductor, capacitors, and resistors. Now we will discuss these components in little detail. Our first component here is resistor. So resistor are passive elements that oppose or restrict the flow of current. Okay, now here you can see a round type of resistor. This is the voltage regulator resistor. You see these type of resistors in your ceiling fan regulator. You just move one cycle, two cycle, three cycle, and it the speed of rotating fan is changing. So this is the kind of resistor here. Now this is the carbon resistor in which the color strip is there. If you want to know the detailed description of color coding and how to calculate the power of resistor, you can mention it in comment. I will make it in different video. So we know that V proportional to IR. This is the basic Ohm's law resistor will follow. Unit is in ohms, and this is the symbol of a resistor. Okay, now second one is our capacitors. Capacitors behave like a tiny rechargeable batteries, store energy and release it later. What a capacitor is? Capacitor is nothing but a energy storage element. Capacitors are made up of two parallel conductors separated by a dielectric. Okay, two conductor plates, and in between we are placing a dielectric. Now, what a dielectric means? Dielectric, in simple manner, dielectric means it has property, it has a dipole and it is property of positive and negative charge. Okay, now they use our filtering, tuning, separating signals, etc. So there are the various application of capacitors. Now the ability of capacitor to store charge is called its capacitance. How much capacitance, how much energy it is storing is its capacitance. So C is equal to Q upon V. Q is here charge. Okay. Now the unit of capacitor is in Faraday. Commonly used capacitor are much smaller than 1 farad. I'm sorry, it's farad, not Faraday. I'm sorry. Smaller than 1 farad. Microfarad is in 10 to the power minus 6, nanofarad 10 to the power minus 9, and picofarad 10 to the power minus 12. So, this is the symbol of capacitor here. Now, our third one is transistor. Transistor is three-terminal device commonly used for signal amplification, switching, and voltage regulation, etc. There are two symbols here. One is NPN transistor and one is for PNP transistor. We will study transistor in detail, so I will skip this side and move forward to another one. Now, this is the symbol of diode here. Diode is also an active device. This is the symbol of diode, and this is the real picture of a diode. It is simply like a PN junction. We will study it in detail, but diodes are semiconductor devices that allow current in only one direction. It is a unidirectional flow of current we have. The second one here is a fuse. Okay, so, if you take the back side of a stabilizer, you see these kind of fuses. So these are the fuse. Fuse are devices that protect the circuit from overload. So this is the basic diagram of a fuse. Okay. So this is the simple, working principle are made up of wire that melt when the current flow exceed in a specific value. So inside this glass, a simple wire is there. So it will break when current is high. Now here, the third one, we have light emitting diode. It is also an active component. So here, it is the diagram of an integrated circuit is here, and here you can see these are the LEDs, light emitting diodes. A specific kind of diode, they allow current flow in one direction. Similarly, like PN junction diode, the LED will light up when the proper amount of current passes through it. Okay, now you have LED displays also. In your television, LED displays. LED display is also there. You can see them in 7-segment display also, in digital watches, in digital not in digital watches, in digital systems where 7-segment display is there. You can see them in digital calculators. You can see now the integrated circuit, which is our last component to study for today. It is a small scale electronic circuit on a substrate of semiconductor material. This is the structure of an integrated circuit, which we called IC. So here you can see IC. These IC are mounted over the PCB here. These are the IC. These are the legs of the IC. Okay. Now today our discussion of electronic circuit and their component is over. I hope you enjoy this class, and I will see you in next class. Okay, bye bye. Take care.